So I'll try and talk a little bit about various aspects of debugging and point you to a place where you can do validation, but otherwise I'm going to focus on how to do a small mathematical expression language and generate code for it. So let's do that, and we're just going to make a new other. And it always sits on xtext project, of course, because that's our favorite. So small exp. Yeah, it's sort of, you have to wonder what to use. Just .x. Okay, let's go with that. That's safer. Good. So okay. So we want a small mathematical expression language. So let's call it mathexp. And a mathexp, that's going to be expression, and then I'm just going to get a name, because then I have something to use when I generate the code, just for purely practical purposes. Is, and then an expression. So like here.
So this language has only one expression?
Yes. Do you want more than one?
No, it's fine.
I guess we could do more than one. Let's we need something else to give us a name. Okay, so let's expression. Let's do this differently. Okay, so expression name is ID, and then and we want a named expression, and we want a whole bunch of named expressions. Named expression. This is name equals ID is, and then x equals x, and then a semicolon, just to be on the safe side. Okay. Now an expression. Now we have to think back to how we were supposed to do things for making a grammar. So what operations should we have in our grammar?
We can have multiplication, addition if you want to keep it simple.
Okay, I like simple. Good.
Logic operator.
I'll take the maybe as, no, we don't really need that. Okay, so let's just have multiplication and addition and numbers.
Yes.
Okay? No variables, because variables means that we have to think about what variables are present somewhere to when we generate code.
Yeah.
So let's just leave out the variables for now. Or we could now let's just not have let's not have variables. I mean, we could also have functions, for example. So a named expression would actually be a function of x, y, z, or whatever. But let's just keep that out for now. Okay. So does anyone remember how to do this? So how do we do it when we want to write precedence? Or do we write precedence between multiplication and addition?
Yeah, we have like, I would say, weak expression, multiplied by parentheses, and then we have weak expression, and then we have.
What do you call it? Weak expression?
It's like the addition. It can be addition.
Okay.
It's addition separated by.
So we, I think we have something called as a factor as well, right?
Yes.
So so a single expression might just be a factor,
And then an operator that is.
and then we have this thing here, right?
Yes.
So we're doing the left factorization at the same time. So so if there's a so we are adding, so there might be an addition here, and a factor.
I was thinking that the factor is actually at the addition, and then you have between them.
Oh right, okay. So this is
because then you put further down the grammar, so you have precedence. So our multiplication is between something.
Okay, let's just call it a weak expression. Okay. So there might be another weak expression that we add into it, like this, right?
I was thinking that the weak expression is the addition, and then you have the multiplication, and then you have with another weak expression, and that is into parentheses.
Oh, and then we need the expression here, of course. So we have, and if in this case this is a binary operation. So there's this current syntax that I always forget when I have to write it. Does anyone remember it?
I was thinking instead of the plus, it's the multiplication there, and then the weak expression is a factor plus another factor. And then you have.
But we want to say that an expression is a number of stuff that's being plus together.
But we want to have precedence.
Yes.
So it's something that is plus together and is multiplied.
But we have a bunch of things that are multiplied, and each of the things that are multiplied are being plus together.
Yes.
Right? So following this, then we would say a weak expression, that's something that has a factor and then can be multiplied with the weak expression. And a factor, that's either a number or parenthesis and then an expression, like this. So is this so because here we're saying, you remember the farther down we are in our layers, the stronger it binds.
Yes.
So here we're saying multiplication binds stronger than plus. Right? Let's go with this for now, and then okay, so let's take this from the bottom, and number, then we have value, which is an integer. Okay, and factor returns an expression, and weak expression returns an expression. Okay. Now, then there's the syntax for the current thing that I never can remember. Curly bracket current. Oh, yeah, and then, okay, so then bin up dot current, no, bin up dot left equals current, and right equals expression. And let's make it a plus operator, plus operation. So this is a plus operation with left and right. And here we have this is a multiplication, so this is a multiplication operation. Dot left is current, and right equals this one. So actually, I would call this a primitive here. So this is these are our primitives. And then I'm going to, because usually when in mathematical language we call these, I think pretty sure we would call this a factor. So, and we can have a number of factors here. Okay. So a named expression, name is some expression. An expression is a bunch of factors that are being plus together. So some stuff with pluses between. So pluses is how we first decompose it. This makes plus the weakest. Inside the things that are being plus together, there are multiplications. So this makes multiplication stronger. And the things that we are putting together here are numbers, and there might be parentheses. I have returns exp on this, so my plus up, so the plus up here is going to be a kind of expression. The mult up is on this that returns an expression, so that's going to be an expression as well. And the number is also something that's been returned as an expression, so they're all going to be expression types. So they're all subclasses of expression, which is what I want here. So this gives us this composite pattern structure, which is very simple because there are only two, there's a left and a right child for the up classes, but that's all. So I think this is our grammar here. Does something look bad now? Because it might very well look bad because, well, we haven't tried this yet. So please, if something looks funny, don't hesitate. Small exp here. Okay, xtext. And then we do run as generate xtext artifacts.
You can also just write the document itself.
Like this. Ah, nice. Now we, just as a quick look, we have the generator that you're familiar with. We have the scoping here is, so this is, xtext has special support for helping you to do scoping. So scoping, the scope of a variable is where is it defined. This has today to do with resolving names. So we have this square bracket notation in xtext that we can use for global name resolution. But if you want to have local variables defined, then scoping here something has facilities. It's a framework that helps you do this more easily. The other one is the validation here. So this is where you can add rules that run and check arbitrary things. The scoping is a special kind of rule, because it's a very special thing you want to do. So xtext has a special framework to help you make that more convenient. The validation is basically anything. And there's a small example here. So basically what you do is you can have any number of classes inside this package here. They should follow the same pattern as this, so they should extend this validator class here. They should have the @check annotation, and then you can make as many methods as you want, just so long as they have the check annotation. And then you say, oh, check this checks greeting, and this means that whenever the parser has been running and the model has been built to give you a greeting object, this is as you're typing, it's going to run this code. And then you can report back if there's something wrong with it. Suppose that you wanted to check that your package name started with, or that, no, that's a bad example. Just a second. So suppose that we had here, actually here we could check that here there's nothing in the grammar that prevents me from writing several expressions that have the same name. So I can write x is something, and then can write x is something again. The BNF doesn't prevent me from that. And xtext doesn't actually disallow this in this case. So I might want to check that. Well, then I would write a rule here that would take a mathexp, and mathexp has a whole bunch of expressions. Let's just add an S here actually. Expressions. So I then would do for each of the expressions, and then I have a set that remembers all names we've seen so far, and if there's any name in this set which is one that I've seen before, then I signal an error. That's actually fairly easy code to write, because I do the checking in terms of the model. The most annoying part is figuring out how to report the error. And there's this code here shows you an example. You have to, there's this package called literals that you have to search a bit for, but which is inside the generated code, that has these things. So for every rule that you use in your xtext grammar, there's a literal symbol like this defined. And you have to find the one. This tells xtext where to point the error to. So this will point to the name part of the greeting here, which we don't know what a greeting is, but that was from the same example. So in this case, I would want to point the error to the name part of the named exp, saying, oh, the problem is actually in the name here, not in the whole expression, which might be a long sequence of math, but in the name here. So that's how you very briefly write validation rules. And I'll show you an example at a later point. I'm going to try this, the fancy, I don't completely trust it. Okay. Okay. And now let's just try and run this. That's funny. Okay. Okay. Interesting. Okay. I just did an update of my Eclipse that might have done something. I'm not sure what the problem is. This is exciting. Remember that, so about debugging, so we talked a little bit about the grammar.
Yeah, I just currently updated it too, and it's messed mine up as well. Fix that. Don't update. Yeah, don't update.
Okay, so I'm just going to hope that everything, that my grammar is completely correct, and go ahead and look at how to write a generator. We then want to find our mathexp here. And so I imagine generating a static Java or Java class that has a static member for each of the expressions here. Let's see, resource.org contents.filter mathexp.next. Let's import this. Generate program, and it uses the file system access. And generate program, that's going to do fsa.generate file, and it's going to be, this is our math expression, me, and our math expression has a name. So that's going to be me.name plus .java. And let's put it in a package. So let's call that math stuff slash plus the name.java. And the stuff to put in that, that's fsa.generate class me.name. Oh, sorry, not let's just make it me.generate class like this. So check what is wrong here. Oh. Okay, so now we are in the generator. And we want something like package math stuff like this, because that's what we decided. Then we want public class me.name like this, and we're not going to have anything funny in it. And then for each of the expressions, we're going to generate a static field. So then we're going to have for e in me.expressions, e.generate named exp info. And let's have an extension method for this as well. So generating a named expression. So then we want public static final, and this is going to be an integer expression, int, and then the name of the expression. So that's going to be x.name. I think it has a name. Yeah. Equals x dot generate exp, and then a semicolon. So this is going to give us one static final field for each of the named expressions in our program. Now expressions here. Expressions might be plus ups, mult ups, and numbers. They're never going to be primitives, because a primitive is either a number or some other expression. They're never going to be factors, because a factor was either a primitive, which was something else, or a mult up. It's never going to be this exp rule, or it's never going to be an exp itself, because x is either a factor or a plus up. So the things we have to deal with are plus up, mult up, and value. Those are the only concrete objects I can encounter in my expression tree. So I'm going to do this as a dispatcher. That's funny. How does it suggest a named exp? So let's make this a so if it's a number, num, like this, then actually like this, then I want to, and the number has a value. So to generate code for number, okay, so does anyone have an idea what's going wrong here? Why doesn't number have a value? I have painfully done this before, and I thankfully remember the problem. Has anyone seen the name number before in Java? There's a class java.lang.number, which takes precedence over my own class here. So number is actually a bad name for me to pick for rule, because it makes a class called number, but by default when I write number here, it means the Java class number, which is not what I want. So I can either write the full package name here to resolve the conflict, or I can change the rule over here. So I'm going to change the rule here because that's probably going to give some nicer code. So then I need to, it's actually very convenient when running like this. xtext artifacts. Okay, so let's say it's a number expression. So the problem, wait a minute, yeah, here I'm calling it exp, but that actually it's called exp inside it, so it should be exp.generate_exp, I think. No? Yeah, and then I need more dispatching rules. So I need def dispatch generate exp, and then the two other things were plus up and mult up. Plus up, pop. Oh, plus up like this. Import plus up. Okay, now this is, so before, see what happened here. So before it was this def dispatch for number exp, but the type of this one is an expression, and I cannot call a dispatcher on something which is some random subclass. The dispatcher function, when it only has one variant, the type is just whatever type is here. But now the dispatcher has two different variants. So now the type of the dispatcher function is the common superclass of the two arguments here. The common superclass of plus up and number exp, that's exp. So plus up, mult up, and number exp all share exp as the common superclass. So when I make a dispatcher, and that dispatcher has different classes that all meet up in this class, that's the type of the dispatcher. So now it's legal in terms of typing, and then I need a multiplication operator and import it. Okay. So now I just need to write the rules for what it means to do a plus and a multiplication. Because numbers were easy, just insert the number. For plus, well, I want to do, that's called pop, and then map like this. So pop has a left and pop has a right. And if I did it like this, I would get this weird, very long xtext internal name. That doesn't make sense because I want to generate the expression for this. Like so. And down below here, in the multiplication, it's going to be almost the same. Except I want to multiply, and I want to call it map like this. Okay, now it's warning me that because it's a recursive function, it cannot automatically infer the type. This is a limitation of the type inference used in extend. So what I normally do is I add the, I think this is a type of just sequence, no. I think so. Okay. Now I explicitly add the return type. I just had to go in the right place. So I explicitly add the return type because the type inference in extend cannot deal with recursive functions. And that's just a limitation of it, which is not uncommon. Okay. Now, so this is actually a generator for my expressions. It's a the expressions are recursive in the BNF. It's a recursive rule. So naturally my generator is also recursive. Right now there is a problem with my generator. Now if my runtime Eclipse was behaving properly, I would run it and I could show you how I could make it do something unexpected. I have a little problem since I cannot, which is very annoying, launch it. But if I was to launch it, then I would. So now we have our, if we look at our program, we write expression test, and then I want to write x is 5 plus 3. This is what I'm allowed to write in my program now, right? I can't do it inside runtime Eclipse because of the stupid runtime error. I could also write y is 5 plus 3 times 7, like this. The code generator is going to generate incorrect code for this program.
For the parentheses,
Yes, what is the problem?
we didn't handle them in the generator.
Yeah, so this is actually the thing, the way this is passed, the code that I would generate for this, I have to write it manually. Because I would generate package math stuff, right? This is my generator running. Public class, let's call it test here. Public class test. Public static final int x equals 5 plus 3. This is my generator running now. And then we do public static final int y equals 5 plus 3 times 7. Because my generator doesn't use parentheses. And now here this is going to be 8 times 7, which is 56. But this is going to be 21 plus 5, which is 26. And that's bad. So I need to fix this. The easiest way to fix it is to worry a little bit less about readability and just put parentheses in here always. Because I know when I have the structure here that I have the same structure as if there had been parentheses. Now if I do that, my generated code, which if I had had my generator running, would have been like so. Which is not so nice, but it sort of works.
So we can do that.
Yes, that is a perfectly reasonable way to generate code for expressions. You can also try to be clever and not generate too many parentheses. But that's just then you write slightly different rules for your code generator. You need more different kinds of rules and checks for if it's this thing or that thing or whatever. I wouldn't worry about it. This is okay.
So also in our grammar, the parentheses have a name, since we are generating them like that.
So in the grammar, I did support parentheses here.
No,
Oh, sorry.
in our grammar, the expression has to have a name also. So we can generate the name like x, y, z.
Here I gave my expressions a name. Is that what you're asking about?
Yeah, I know that, but if we have to use it in our project,
It depends. I mean,
then they don't have to write actually a name.
No.
of the expression.
like if the expression is if some expression, that's suppose that your DSL has if some expression do something,
Yeah.
then you don't need to give it a name. I gave it a name here because someone suggested that we should have multiple expressions.
Okay, makes sense.
Otherwise, I would just have made a single method that returned an int or whatever. So that's it. Now, hopefully this works. I will check it as soon as I resolve the whatever is the problem with the runtime Eclipse issue.